Welcome to Code Camp. It's so nice to be here again. I've got a lot to talk about microservices and some of the lessons. This must be using microservices. Anyway, I've been using microservices, or been involved with microservices for about the past 12 years. And I've seen a lot of things that work. And I've seen a lot of things that don't work. We've learned a lot in the past 12 years of microservices, and that's what I want to show you today. Some of those lessons learned after 12 years of trying to create microservices applications. So I'm going to go through a series of topics and the lessons learned from those topics so that we can kind of try to, at least, to create a more effective microservices. So the first topic here is about the bounded context. So we learn about the bounded context from domain-driven design, and we understand it's where the ubiquitous language of our model lives. And certainly we can learn a lot about domain-driven design from all these really great books. So what we do is we do domain-driven design. And we come up with our domains, our subdomains, our bounded contexts, and we spend all this effort doing this. And then we go to implement microservices. Where is that bounded context? Well, let's find out where it is. So when we look at microservices, it's an architecture style that is separately deployed functions, all deployed individually, all owning their own data. This is kind of the shape of microservices. Did you ever wonder why we have to do this? Because this is hard. Why we all have to have our own data. Now, maybe it's a database, maybe it's just a collection of tables, but each microservice has to own its own data. Why? Why can't we just all share the same database and all get along? Well, the first thing we see is that we've got all these great auto-scaling capabilities within microservices. Oh, Kubernetes will just kind of auto-scale anything we want to. What else has to scale? The database. And a lot of times, it doesn't scale. And suddenly we realize, oh, we can't share a database, and we see our very first dumpster fire. So, that's why can't share a database. But there's another reason. Because what if I want to apply a change? And that requires a change to the structure of that database. I would have to go and find every service that needs that change. And I would have to apply that change to each of those services and try to coordinate all of that when I release. That's hard. That's only half the story. Because we do all that coordination, we release, and we forgot about services that were using that table. And we see yet another dumpster fire. This is why each service needs to own its own data. But I still need this data over here. So what do? I go and access that data. Well, wait a minute. If I still apply a change, I have to change my table. But now, I have to change other services. And again, somebody else may have been calling me, and all of a sudden, another dumpster fire. This brings us to our very first lesson learned. And that is that microservices will never work. So don't do it. Multimask. Oh, here's my chair.
That was very good.
Wait, what? It's a short talk. I know we're running kind of. What are all of you still doing here? No. It will work. And that's what that bounded context is all about. You see, when we associate a bounded context with microservices, it's actually manifested through a physical bounded context, where a service owns its own data. And the point is we have our domain bounded context, we have our physical bounded context, that now starts to form this association. But in order to get microservices to work, you cannot access my data. This is called intrusive coupling, the worst and strongest level of coupling there is. Instead, you have to ask me for that information. And that is actually a representation of the bounded context consumer-supplier collaboration patterns. And so we can start to see now where everything kind of fits. So now, if I go to apply a change, I have to change my own data, and everything else is just fine. So we see our very first kind of lesson learned in microservices. If we want to avoid those dumpster fires I showed you, pay attention to the bounded context, because it is the only way to get microservices to work. Okay, this is true. However, how realistic is this? There you go. Yeah, those who have done microservices is not very. And this leads us to our second topic of effectiveness: data sharing for fun and profit. So the idea here is this: we have a bounded context, but this kind of pattern, where each service owns its own data, is actually called a database per service pattern. It's doable in the cloud. And it's actually not that difficult to create. You see, we take our database and we take all the tables, we assign ownership. A service that writes to the table owns that table. We form the nice, well-formed bounded contexts, and we're done. It's not that hard. Or is it? You see, what else do we have in that database besides tables? Oh, we have foreign key constraints. We have views. We have triggers. We have stored procedures in there. And now, when we go to try to create these bounded contexts and a database per service pattern, look what we have here. It would actually require us, as a matter of fact, I like that, let's do that. It would require us to cut every one of these lines. Do you realize that there is actually in our industry now, thank you microservices, a shortage of DBAs? You know why? Can you imagine walking up to your DBA, looking them straight in the face, straight in the eyes, and saying, we're moving to microservices. We need to remove every foreign key in the system. We need to remove every view, every stored procedure. Well, what happens? The DBA's head turns red. It starts shaking like this, and then it goes boop, and it pops right off their head, right off their shoulders, pop. I mean, it's quite messy, but it's quite fascinating to watch. Yes. No DBA is ever going to let you remove every foreign key. But listen, that was what would be required in order to form these kind of bounded contexts. How realistic is that? Not very. This was one of the hundreds of initial challenges that I faced with microservices and trying to implement this really hard architecture style. So what do? We try to do the database per service pattern, but rather we share data. You see, by sharing data, now I form what's called a data domain. All those tables associated with that domain and all of the foreign key relationships, the views, the triggers, the stored procedures, are all preserved. Now, we do have to cut the lines of those relationships that span beyond these bounded contexts. But what this forms is more of a broader bounded context, where we can now actually share data. So we still have a physical bounded context. It's just broader. Why would we ever do this? Let me show you 3 reasons why sometimes we have to do this. Highly semantically coupled data. That is tables that either have physical relationships, foreign keys, views, triggers, or procedures, or maybe it's a logical relationship where our customer profile information is spread across 4 different tables. And so the idea here is if our data is highly coupled, this allows us to preserve some of that coupling. What if I have 2 or more services that own the same table? We update different columns. That would be another good justification. If I can't access data that I no longer own, I can make a RESTful call to get it. That's expensive. I could try to use caching, maybe, but we have too much data. And so this becomes our 3rd use case. When I have to read the data, do those same kind of joins and queries we used to do before, that's the other use case. The negatives? Yeah, there's 2 of them. Unfortunately, the first one happens to be more change control. If I update this table right here, or update the database, I now have 3 services I have to coordinate. But at least they're known services. I know about those services. And also, basically, scalability can be impacted. Because as I scale those services, I might have to scale that shared data as well. So this brings us to our 2nd lesson learned. And that is this, that it's okay, and sometimes necessary to share data in microservices. It is okay. Well, this leads us to our 3rd topic. Because if we could share data, which we can, and we do, I call this pragmatic or realistic microservices, then why in the world would we have separate services in the first place? This just keeps going backwards and forwards and backwards and forwards. Well, let's investigate that. And that brings us to our next topic, service granularity. Well, Mark, so you're saying that, yes, we can share data, but you've got 3 services sharing that data. Why do we then have 3 services? Back in 2015, I coined an anti-pattern. And that anti-pattern was called the grains of sand anti-pattern. I coined it because of my experience in most companies doing microservices, that we start out and we make our services as small as possible. Everything, every bit of functions as small as possible, just like the grains of sand on a beach. And all it does is lead to a big ball of distributed mud, or a large distributed monolith. Turns out, service size, the size of a service, does in fact matter. So what size should a microservice be? How big should we make it? How small should we make it? That's easy. Mark, the word micro. Micro means small. We all know that, so services should be small. How small is small? How big is small? What if I had a microservice with 3 class files here? What do you think? Good? Yeah, that's probably micro. What if I had one that had 300 class files? Microservice? Macroservice? Mini application? What do you think? Is that a microservice? Turns out it is. Because the definition of micro does not refer to the physical size of that service, but rather what it does, its purpose. That's what that word micro means. 300 class files? Come on, Mark, you know what that does? That sends emails to our customers. That's all it does, single purpose. Does one thing really, really well. It sends emails to our customers. Now, there's only 2 class files here involved with sending the email to our customer. But we have 298 different emails that we send Using the strategy pattern, each of those emails is in a class file. Instantiate it, pass in the data, class does all the formatting, gives it back to me, I send it. 300 class files. So it's a good lesson learned not to pay attention too much to the physical size, the number of lines of code, the number of classes, but rather what it does. Okay, which comes back to our question. Why, then, do we have separate services? Should we? If we're sharing the data, shouldn't we push these back together? Maybe, maybe not. In the immortal words of every architect on the planet, yes, it depends, of course, but it depends on what? Turns out that there are two forces, granularity integrators and granularity disintegrators. Disintegrators say, no, we should keep those services separate, or we should continue to even break these apart. What are those disintegrators? The first one happens to be the service functionality, cohesion. You see, do all these do the same thing? No. Each of these have a different function. That's why we keep them separate. That might be one reason. So, another reason is code volatility, the rate of change of code. You see, this service right here changes all the time. These services rarely change. It's a good reason to break things apart or keep services separate. You see, my testing scope is smaller. It's easier to apply a change, easier to deploy, less deployment risk, and while that service is being deployed, I'm not disrupting any other functionality. So that's a pretty good justification. Other than that, maybe it's scalability and throughput. You see, this service over here on the left-hand side scales quite a bit. 200,000 requests a minute. This one only 500, this one 10. They all have different levels of scalability. Another good reason to say, no, that's why I want these apart. Even though we're sharing data, we should still break these apart. And then the last happens to be fault tolerance. You see, this service over here always crashes. These two are pretty stable. Another good reason to break our services apart, make them smaller. Well, those are good reasons, Mark. But when should I consider putting them together then? Well, let's investigate that. So the first is data dependencies, exactly what I'm showing you here. So if we all are dependent on the same data, and we have no good reason to break them apart, then yes, in fact, we should put them together. So every time I make a change, I'm going to have to coordinate 3 different deployment units for no reason? That's silly. Yes, put them together. That's our first integrator. Our second one might be transactions. You know, if a user here goes and executes a request, that's no longer a database transaction, because all these updates that start happening are separate commits in the database. So if we require an asset or a database transaction, I don't have it. I have a distributed transaction. By bringing those services back together, making it more coarse-grained, now that same user request, now all of a sudden I've got much better data consistency and data integrity. I can do those commits and rollbacks against that unit. Another good reason. The third and final integrator happens to be workflow and choreography. You see, with separate services here, user goes and makes a request, and all of a sudden, I get an error. Ooh. Well, in that case, whoops, let me go backwards one. Let me try that again. There we go, yes. So the service is unavailable, it's non-responsive. What do we tell the user now? I've already committed some work. That gets really difficult. The other happens to be scalability. Or now, let me try this again. So now, watch this. Look at how long that took. Latency. It's too slow because all of these services are all interconnected. And so the key here is, as this kind of integrator, now, first of all, I have much better fault tolerance, and it's much faster. These are the drivers for making the decision about whether we should break apart a service, whether we should put the services back together, and what size they should be. And this leads us to our next lesson learned. And that lesson learned is this: granularity is not a guessing game. It requires justification of those granularity disintegrators and those corresponding integrators that bring all of it back together. Okay, so far, we've taken a look at the bounded context, how microservices works, and that kind of lesson learned. We then took a tour here now of the granularity. But granularity is not a guessing game. Well, I wonder, these two are good lessons learned, but why are we still struggling so much with this extremely complex architecture style? And this leads to our third topic and lesson learned. And it all has to do with isomorphism. So isomorphism does matter. And I'll explain what I mean by that isomorphism in a little bit. So we expect a lot of constant change in our system, and also we need to get those changes released as fast as possible. Also, we need this in the next 6 months, and we expect a lot of growth in the next 6 months, particularly as we aggressively gain new customers or gain new businesses, acquire them. That's our problem. I wonder, is microservices a good fit for this? Well, in our book, The Fundamentals of Software Architecture, Neil Ford and I took a painstaking 7 years and created star ratings for every architecture style against a lot of different architecture characteristics. 1 star means, nah, if you need the scale, it's not going to happen really with this architecture. It's not well supported. Whereas 5 stars means that's what that architecture is meant for. So we can use this as guidance to do qualitative analysis. Based on that problem statement I just showed you, what's important to us? Now, I call these architecture characteristics. Owen had mentioned these as quality attributes. Some people call them non-functional requirements. Neil and I both prefer the term architecture characteristic. It's a characteristic the architecture needs to support. You see, I don't like non-functional requirements, because the minute I go up to my product owner and say, hey, can we have a meeting? I'd like to discuss the non-functional. No, Owen was absolutely right. I'm not concerned about anything non-functional because we have to get these features in this iteration. Yeah, people will ignore you. System quality attributes, for me, implies this after-the-fact polishing of our application, when in fact these form the foundation of our systems. So these are the ones that are important to us. Does anything stand out to you as a almost exact match? You bet. Microservices. Every one of those concerns on that problem statement, microservices has 5 stars for. Clear choice. So, what do? We've got microservices. Okay, so what do? We implement it, go into production, and what happens? Turns out that all of these services need to communicate with each other, and we're communicating, we're talking, and you're talking to so-and-so. And what does this look like? An epic failure. But Mark, wait, we did everything you told us to do. We used your star ratings. We matched it up with the characteristics, and it's a perfect fit. No, it's not. Why? This is one of the reasons we are struggling so much with microservices. It's all about isomorphism. Isomorphism Comes from two Latin words, isos, meaning equal, and morph, meaning form or shape. And we're asking this: does the shape of one thing match the shape of another? And this is almost like putting a square peg in a round hole. Well, we can extrapolate on this concept of isomorphism to talk about architecture to domain isomorphism. How close does the shape of our architecture match the shape of our problem? That's why microservices is so hard to build. There's too many times those shapes don't matter. Now, every architecture style has a shape. Every problem has a shape. Here's the shape of this problem. We have high time to market needs. We've got large huge volumes of data, and we need really fast performance. That's the shape of our problem. We're able to describe it through a shape. What's the shape of microservices? Single-purpose functions deployed as separate units of software, each owning its own data. We put on top of that shape things it does really well: scalability, fault tolerance, agility. All of these, extensibility, make that a particular shape. So, isn't it interesting? What's the shape of our problem? Well, we can describe our problem. First of all, we have large monolithic data. We have very tight time frames and budgets to deal with. Also, we have teams organized by, I don't want to use the words, Conway's Law, where we have groups of UI developers, groups of back-end developers, groups of shared services, groups of database folks. Yeah, that's a shape of our problem. And most of that functionality is all needed. I mean, it's not like independent, separate functions. No, we have lots of workflows and stuff like that, highly semantically coupled functionality. That describes a shape of our problem. And now we can ask, does the shape of the architecture that we chose, or are using, by the way, if you think about the one you're using now, actually match the shape of our problem? Because in too many times, it doesn't. That's why microservices doesn't work. It's not the right architecture. It's not the right shape for your problem. So, what kind of shapes do work? Well, certainly high agility. When we have to get a change out or a feature out faster than our competition, that's a good shape. When we have high scalability, elasticity needs, maybe it's high fault tolerance, or maybe it's cloud deployments, it's another good shape. When we have a problem where we have lots of individual entities, they don't really talk to one another, and also on our problem that we have lots of independent functions that we tend just to group together in an application, that's a shape. That shape matches microservices really well. So the lesson learned here is this, that microservices does have a very specific shape. And it's not always a fit for our problems. Yet we try to make it fit and struggle. There are about 9 to 10 other major architecture styles that may be a much better fit, a much better shape for your problem than, in fact, microservices. So isomorphism, turns out, does matter. It matters a lot. Interesting. So that leads us to our next topic. Because how many shapes then do fit microservices? Turns out, not many. And that brings us to our next lesson learned. And that is about hybrid architectures. You see, here's our problem statement again. We need a system that can support an increasingly large number of customers. Also, bug fixes and new features must get to our customers as fast as possible. Bottom line, user or customer satisfaction is the most important thing for us. That's our problem. That's our shape. Okay, well, let's go back over to our star chart. And what do we find? We find microservices actually fits perfectly again. Now we're back to square one. But the other thing to pay attention to is the bad stuff as well. You see, for all those good 5 stars, there's a lot of kryptonite built into microservices. I have been in this industry for 36 years, 26 of those as a software architect, and the past 12 years devoting most of my career to microservices. And I've designed and implemented all the architecture styles, and I can tell you, this thing called microservices is the hardest thing I've done in my career. It is complex. Not because it's not technically complex, it's because of all the other things that need to happen in microservices, all the choices that we have to make. What do you do with shared code? Should we create a shared library? Should we use a shared service? Should we replicate the code? What do we do about contracts between services? Should they be tight contracts, strict, loose contracts? What kind of contract should it be? JSON, XML? What kind of database should we use? How should we communicate? What sort of protocol, synchronous or asynchronous? Should we use orchestration or choreography for our workflows? Should I manage distributed transactions through atomicity or eventual consistency? These are just a few of the many questions that you have to answer when doing microservices. It's hard stuff. It's also not high in performance because of all the latency of communicating between other services and the security latency of authenticating or maybe reauthorizing for those. Or maybe it's the data latency of having to call the database 15 times because we all own our own data. It's not very performant. So what do? We move to microservices. Dum-da-da-dum. Okay. And here is our customer kind of facing area, and here's our admin area. Seems to be a fit. Isomorphically, it's working fine. Star ratings work fine. But let's actually analyze this. So here's the superpowers of microservices. 5 stars. Well, who needs this? Definitely needed in the customer area. I mean, high scalability, deployability, testability, so we don't keep introducing bugs. All of these are needed. But they're not needed at all for our back-end functionality. This is one of the mistakes that I see every single day. We do all the right things. We find out what our architecture characteristics are. We do the isomorphism and we come up with this, and we're still not doing it right. Why? Because of the kryptonite. Now, for customer, we know about this. We're willing to trade off some level of performance and complexity and cost in order to have all those superpowers. But on the back end side, no. I'm getting all of the pain with no benefit whatsoever. And once again, guess what, everyone? We find we have an epic failure. I should probably bring that other slide up about microservices will never work, don't do it. Yeah, it kind of seems that way, doesn't it? But no, because this brings us to our last lesson learned. And that is this. Hybrid architectures are the new king. You see, moving to microservices, migrating to microservices, maybe doing a greenfield or brownfield to microservices, is an epic failure. What we have learned over the past 12 years is this. Moving here to service-based architecture first is, in fact, the secret sauce. This is an architecture style that is a hybrid of microservices. It sort of looks like it, where we have domain services, services that encompass an entire domain. Move here first, because now we can ask the question, who needs these superpowers? Well, definitely needed up in customer, not needed at all in our back-end functionality. So we place where we need them, and that's what we convert and move to microservices. This, everyone, this is a perfect, beautiful architecture, because that's microservices, and this is service-based. This happens to be my secret sauce, whether I'm doing greenfield, whether I'm doing a migration. So, our lesson learned here happens to be this. Not every portion of an application has to be microservices. That is exactly where we get into trouble. It's related a little bit to the grains of sand, where, we're doing microservices. What should we start with? Start with that functionality, this and this, and we just start creating services like crazy. Somewhat related to that, but this is a powerful lesson learned. All right, so let's review our lessons. So lesson 1, remember, pay attention to that physical bounded context. Always question if I'm breaking or stretching that physical bounded context, because that is the only way microservices will work. Our second lesson learned, it's okay and sometimes necessary to share data. Just make sure that you have a good justification for doing so. And we learned about those 3. My data is highly coupled. I can't get rid of all of those foreign keys and triggers and stored procedures. We kind of need those, but we want to move to microservices. Keep them. Keep them. Multiple owners of a table. Queries that are so complex that it would take us forever to implement those in our source code. Yeah. Lesson 3, granularity is not a guessing game. It matters. It matters. And we learned about granularity disintegrators and granularity integrators. Next lesson, microservices does have a specific shape, and isomorphism does matter. Think about, after the conference, the shape of your problem. Try to describe it in terms of those architectural characteristics that are needed. Try to look at the problem in terms of the environment. Maybe it's data. Maybe it's some complex processing, bottlenecks. You can actually define a shape of your problem. And then look at the shape of the architecture you're using. Does it match? Because if it doesn't, it will never work. And finally, probably the most important lesson learned over the past 12 years, that not every portion of an application has to be microservices. Embrace hybrids. There's a lot of common ones. Space-based microservices is extremely common. Event-driven microservices is another really common one. Service-based microservices is probably the most common one. These are hybrids, which now satisfy all the different parts of our system. And those, my friends, are some of the many lessons learned in microservices over the past 12 years in this journey. And I'm sure when I come back next year, I'll have 6 more for you. All right, well, thank you all so very much. Thank you. Okay.